Okay, so first in this lectures, we'll do a deep dive into the EC2. So EC2 is a very big topic, and but hopefully this is something that you already be knowing at a very high level based on your previous experiences. And I will try to summarize everything that's going to be important and going to be in the exam. So first, when you have an EC2 instance type and they have different families. So first, when you have an EC2 instance type and they have different families, you have R, so which is for example R5.xlarge. So that is usually for application that needs a lot of RAM. Okay, R RAM. Okay, so for example, in memory cases would be great. So C for applications that need a good amount of CPU compute capacity for computation. So they are great for databases as well. M for medium, M for something, M for which is for the balance, M is for something like medium, which is for general web applications. I, which is when you need very good local IO input and output. So this is when you have an instance store attached to your instance. Instances are attached to your instance, and this is great for high performance databases also. G, when you need to have GPU. So when this is when you are doing machine learning or video rendering. Some of the example would be G class, G4D and .x large, G4D 2x large, 3x, 4x large, 6x, 8x large. So those are the G class instances, and then you have different kind of smaller instances. Smaller instances or T2 or T3 which are burstable up to certain capacities. So there are instances that need to react very quickly and good performance in case of spikes, but gets a baseline performance that's average in the meantime. And then if you have T2 or T3 unlimited, you can get unlimited burst. If you have a very specific type of workload, finally, if you need to find the right instances for you, you have this website, that's EC2 instances.info. So this is now have been changed to the vantage.sh. It will redirect to the vantage.sh or something. Finally, if you certainly write instances, you can even see the AWS documentation. That documentation is even the updated one, and the pricing will be updated. But some of the even this website is instances.info recommends that for the pricing, you can see and pricing information, you should look at the AWS documentation. Okay, so now we that based on the EC2, we have different kind of families, and each family is appropriate. This family is appropriate for different kind of workloads in terms of if the EC2 instance type is optimized for the workload, then the workload will finish faster, and we are probably going to need to pay a lot or lesser. Some of the instances I would actually mention here that P class instances, P2 generation, P3 generation, and those P2.16x large, P3.16x large. These instances are having around highest GPU capacity, like around 16 GPU, all of the 16 gigs, and the RAM is topping up to with like 600-700 cores, around the 196 cores or something like that. So these are some of the biggest instances I have used on the AWS, and like the cost even is going to be around $28 per hour. So it's a big running out of the 1 day, 1.5 day, and we are going to cost around like $1,500 charge. So, and those all we have used with the AWS SageMaker instances there for some of the machine learning tasks, as because just we are getting the P3 instances for only for the machine learning related stuff, and very big GPU farm. So this is what the AWS, all of the instances, families, and generation comes in. Okay, so next, when you launch these EC2 instances, you have to place them. Okay, and by default, when you launch an EC2 instance, it's placed randomly in AWS data center, and you just have it right away. But you can tell or hint to AWS where you want your instance to be placed, and that is the purpose of placement group. So you have multiple strategies. The first one is cluster, so where you want all your instances to be within the same AZ into a cluster, same AZ into a cluster, same availability zone into a cluster, and that will give you a low latency group. So this is great when you want to perform some high performance computing. So HPC, next you have a spread where you want your instances to be spread across the underlying hardware. So you don't want it to be on the same rack, uh, like and so it's a maximum of 7 instances per group per AZ per availability zone, and these are for the application that needs to not have a hardware failure. That's where you will be using the spread group strategy. Hardware failure. So by having a spread instance placement group, you will have your instance very far away from each other. They are spread out and therefore they won't fail all at once. And the partition is when you have a higher number of EC2 instances that you need to place them across different partitions. And this is when you have, for example, something like Hadoop, Cassandra or Kafka. So these are great for a partition placement group strategy. Okay, it is possible, and you need to know this, that to move an instance into or out of a placement group, first you need to stop that instance, then you need to use the CLI to modify the instance placement. So you were saying in this placement group or out of this placement group, and then you can start your instance and it will be in the placement group you need. So it's very important that you know this, and it could be done through the CLI. Next we have placement group of type cluster. So that you will each do a deep dive on. So this is what a cluster look like. This is what a cluster looks like. All the instances are going to be on the same rack and the same availability zone, and the idea is that we get a great network. So we get 10 gigabytes per second bandwidth between these instances, so they can communicate very fast with a very low latency. The cons that if the rack fails, so if the underlying hardware fails, then all the instances, because they are placed next to each other, so they will fail all at the same time. So and when we have such a cluster placement group, it's great to choose an instance type that has enhanced networking, because they will have faster networking capability between each other. So the use case for a cluster placement group would be a big data job. Certainly we run the EMR clusters somewhat of similar on the similar rack, elastic map reduce, elastic Kubernetes service, because they will have the fastest networking capability. So the cluster placement group would be a big data job that needs to complete very fast hypercomputing or applications that need extremely low latency and high network throughputs, but at the risk of failing all at once. So spread, here it looks like we have different hardware across different availability zone. It has been shown here the US twist 1A, 1B, 1C, and different EC2 instances on the different hardwares. So, and each EC2 will be placed on different hardware up to the 7 EC2 per AZ, that's the limit, and that gives us some good pros. The first is that you can span across multiple AZ, and the reduced risk of simultaneous failure is really low. And EC2 instances are on a different physical hardware. EC2 instances are on a different physical hardware. Now for this cons, it's up to only 7 instances per AZ per placement groups. So you are limited in a scale, and the use case will be, and the use case here will be for an application that need to maximize high availability or critical applications where each instance failure must be isolated from each other. So this is the safest kind of deployment for your applications from the failures. And the last one, the partition. So the partition is a little bit different. Okay, so your AZ will be divided into the multiple partition. US test 1A, A group, AZ A is divided into the multiple partition, partition 1, partition 2, partition 3. Under these partitions, you have the EC2 instances, okay? So, and then your EC2 instances will be spread across all these partitions. And you get up to the 7 partitions per availability zone, and that gives you 100 of EC2 instances. For the partition kind of placement group, and the instances in the partition do not share racks with the instances in other partitions, so you have again some separation of hardware. Partition failure can affect many EC2 instances, but it won't affect other partitions, and EC2 instances can get access to which partition they belong to. So thanks to the EC2 metadata service, so the use cases for this would be like HDFS, HBase, Cassandra, Kafka, and you can get the metadata information even. Next we have, okay, next we need to know how we can launch an instance. That's very important going into the exam. So we have on-demand instances. They are short workload, predictable pricing, and reliable, but they are a bit more expensive. The expensive ones, not from the dedicated ones. And there are the spot instances, and the spot instances are going to be great when you have a short workload and you want to run it for very cheap. So here you can run the risk of losing the instances. So in the final exam, if you are looking for reliability, spot instances are not going to be as reliable as the on-demand instances. For example, then you have the reserved instances, and it's when you want to get into the cost savings. So the minimum amount of time you can get a reserved instance for is going to be around the 1 year to the 3 year. So minimum is the 1 year. So you have different kind of reserved instances. So the first one is called the reserved instances, or RI, which is for the long workload. Then you have convertible reserved instances for long workloads with flexible instance types. So you can convert them like the convert them. So you can convert them between the instance types, flexible to convertible, or something like such a situation happens. So dedicated instances where no other customers will share your hardware, and the dedicated host where you get access to the entire physical server, dedicated host, entire physical server, and you get control over the instance placement. So a great use case for the dedicated host is going to be when you have software licenses that are going to operate at the core, or the CPU circuit level. So that means you are going to pay for the number of cores or the CPU circuits you have provided. And something you need to know that's very important is that you can define something called host affinity, so that if an instance is rebooting, they are kept on the same host. So if you don't define host affinity, it's possible that your instance will get onto another host. But if for some licensing reason, obviously you need to make sure that the license reboots are kept on the same host, then the host affinity is something you can define for your dedicated host. Okay, now for including metrics in EC2, we know there is CPU where you get digitalization as well as the credit usage and the balance for the T2 micros, T2.micros instances. The network in, network outs, the status checks will be varying, will be very important to know them. So you have instant status where you can check the EC2 virtual machine, and system status where you can check the underlying hardware, and this is AWS that provides these metrics for us. So the disk where we can look at the read write for ops and bytes, and this is only when you have an EC2 with an instance store. Okay, and this is only when you have an instance store, and otherwise you can get these metrics for the EBS volumes directly. And something extremely important that I think I have said all the time on my courses, which is that RAM is not included in the EC2 matrix. and you need to push them directly from the EC2 instance into the CloudWatch as a custom metric. RAM is not included, RAM consumption. Okay, so if you need it, you have to push through the CloudWatch as a custom metric. Okay, now let's talk about the EC2 instance recovery in detail, because it is something you must need to know. The status checks, we have two, as I said. The first one is the instance status, and then we have the system status. And so something we may want to do is to recover an instance in case these status checks are failing. So here what it look like. Our EC2 instance is going to be monitored by a CloudWatch alarm, and this CloudWatch alarm currently is set up to be checking the status of the system status check. And so in case it fails, how you use your CloudWatch alarm to define an action called the EC2 instance recovery, or to recover your EC2 instance. The action of using an instance recovery is that you will remain, obviously something will be lost, but you will keep the same private IP, the same public IP, the same elastic IP, the same metadata, and the same placement group. So this is something quite nice. If you have an instance and it's critical and you want to make sure you can recover it in case anything goes wrong at the instance level or the system level. So in which case setting up a CloudWatch alarm, setting up a CloudWatch alarm that will perform an EC2 instance recovery action is a great way to do it. Finally, because it's a CloudWatch alarm, it can alert an SNS topic, and you can chain it up with the other kind of actions. For example, for notifying a Slack channel in case you need to be aware that your instance has been recovered. Okay, so that's all you need to know for EC2. Very, very important. Hopefully this is not too much new stuff for you, but remember, it's all really important going into and it's going to be very, very important for the exam that you know all the details. All right, that's it. I will see you in the next lecture.